Okay, let's just dive right in. Today, we're talking about an idea so powerful, it served as the bedrock of truth for over 2,000 years. It's a story about a blueprint for reality, how it was challenged, and how that challenge completely reinvented our understanding of logic itself.
And this wasn't just some minor historical footnote. We're talking about a full-blown revolution. I mean, when the mathematician David Hilbert called the discovery of non-Euclidean geometry the most suggestive and notable achievement of his time, he was saying that questioning this ancient blueprint was one of the most profound intellectual leaps humanity had ever made. So, how did we even get there?
Well, our story begins, as so many do, back in ancient Greece, with a single book that tried to build a world of perfect, unshakable certainty.
For more than 2 millennia, Euclid's Elements wasn't just a math textbook. It was the standard for rigorous thought. It was the gold standard. If you could prove something using Euclid's method, it wasn't just a theory, it was considered an absolute, undeniable truth.
The genius behind it all was this system called the axiomatic method. And think of it like this. You start with just a few foundational beliefs that are so incredibly obvious, nobody can really argue with them, right? Those are your axioms. From there, using only the tools of pure logic, you build piece by piece an entire skyscraper of complex and proven truths.
In Euclid, he had this really clear, elegant process. First, define your terms. Simple enough. What's a line? What's a point? Second, you state your postulates, those fundamental, self-evident truths. And finally, you build your proofs, one logical step at a time, making sure every new conclusion rests firmly on the ones that came before it. It was this perfect chain of reasoning.
For the ancient Greeks, this was way more than just a way to measure land or build temples. This was a celebration of the human mind itself, the ability to start with simple truths and reason your way to these profound conclusions. That was seen as one of the greatest glories of humanity.
And for 2,000 years, the answer was a resounding yes. The system seemed flawless, and the truths it produced felt absolute. But if you looked really, really closely, you could start to see a tiny little crack in that perfect foundation.
And this is where our story takes a really dramatic turn. This is the moment the world of certainty starts to crumble.
So the first signs of trouble were super subtle. Scholars started noticing that every now and then, Euclid's proofs made these little intuitive leaps. He was kind of using information he could see in his drawings rather than information that came purely from his axioms. It was a tiny cheat, really, a reliance on human intuition instead of cold, hard logic.
But that little crack, it opened the door for a much bigger, much more radical question. See, for centuries, everyone just assumed axioms were self-evident truths about the universe. But what if they weren't? What if they were just the starting rules for a game? And what if you could choose different rules?
This was the fundamental shift. The old Euclidean view assumed axioms came from our experience of the world, like the fact that parallel lines never meet. The revolutionary non-Euclidean view said, nope, axioms are just starting assumptions that we choose. So what happens if we choose a different assumption? What if we decide that through a point, you can draw multiple parallel lines, or maybe even zero? Suddenly, you have entirely new, logically consistent geometries that can describe things like curved spaces.
So this is the key takeaway, right here. The revolution wasn't about proving Euclid wrong. It was about realizing that his geometry was just one possible logical world. By changing the starting axioms, you could create other equally valid worlds. Truth was no longer this single absolute thing. It was relative to your starting assumptions.
This whole philosophical earthquake left mathematics needing a new foundation, and that's where our final character, David Hilbert, comes onto the scene to build a new, more rigorous blueprint for the modern age.
Hilbert saw the incredible potential in this new way of thinking. So instead of trying to patch up Euclid's old system and its little reliance on intuition, he totally embraced the idea of formalism. He set out to build a version of geometry so rigorous that you wouldn't need diagrams or intuition at all, just pure, unadulterated logic.
And his impact was absolutely enormous. Not only did he create the definitive, modern version of Euclidean geometry, but his method became the blueprint for how pretty much all of modern mathematics is organized. This idea of building entire fields from just a few clear axioms, it spread everywhere, even inspiring people to try and do the same for physics and other sciences.
So the modern goal had totally changed. The quest wasn't about finding the one true description of space anymore. Instead, it was all about perfecting the logical engine, that axiomatic method, which you could then apply to any set of starting assumptions just to see what kind of universe it would create.
So where does all this leave us? With some system of pure cold logic that has no room for human creativity? Well, not exactly.
It's really easy to think that once we formalized everything, we might have lost something important along the way. That maybe the beauty and intuition that drove the Greeks was just replaced by a rigid game of symbols.
But that just isn't the case at all. The pursuit of mathematical beauty, of finding elegance and simplicity in proofs, is still a powerful driving force for mathematicians today.
And this quote just captures it perfectly. Geometry, because it's so visual and intuitive, is often the gateway for people to experience that profound beauty. It's where the abstract becomes tangible and logic itself takes on a kind of aesthetic quality.
Which brings us full circle. It turns out that the very thing that was a subtle flaw in Euclid's original work, his reliance on diagrams and intuition, is still an absolutely essential part of mathematical discovery. The formal proofs provide the rigor, for sure, but it's often human insight and visual thinking that spark the next great idea. It's this incredible dance between creativity and absolute logic. And so we'll end with this thought. The story of geometry shows us that one of humanity's most long-held truths was actually just one possibility among many. And it really makes you wonder, what other absolute truths in our own lives are just the result of the starting assumptions we've chosen to accept? What happens if we dare to change the rules?